Hey pre-calc people, today we're going to do an introduction to limits. So we've talked about limits before in terms of end behavior, and these aren't going to be all that different than that. We're just going to be looking at them kind of limits at different points in the function. So we're going to look at them graphically mainly for today, but we'll also use a little bit of functions to help us with that. So anyway, here we go. Looking at limits. So if I've got let's say we want to find the limit of the function 2x plus 1 as x goes to 2. Okay, so if I were to draw this for a moment here, let's see. There's my line. It's so lovely and straight, I know. But anyway, if we wanted to look at the limit as x goes to 2, usually what we're used to looking at when we're talking about end behavior is like as x goes to infinity or negative infinity or something like that. But we've also looked a bit at limits at different values. Sorry, my dog is... Get off. Okay. Where were we? Limits. Limit as x goes to 2 of 2x plus 1. So basically what we want to do is look at the graph where x is 2. And notice what value the function is going towards from both sides. In this case, it's going towards the actual value of the function, which is 5. So the limit as x goes to 2 of 2x plus 1 is 5. So, and that one was pretty visually obvious, right? It's clear that it's going to the exact value of the function at that point. And then sometimes, though, limits don't equal the function value. So that's what we're going to look at next. They might not equal the function value. So, for example, if we have something like we wanted to find the limit as x goes to 3 of x squared minus 9 over x minus 3. So that function looks like this. And it has a hole in it at 3 because we can't plug in 3 because we would get 0 in the denominator problem. So in this case, the function value doesn't exist at that point, but the limit does. So if you look at the behavior of the function, what it's going towards at that point, let's see, we would notice that it's going towards 6. So the limit can still exist and be 6, even if the value of the function does not exist. So that's kind of a brief intro to limits there. Now let's talk about one-sided limits. So there's two things, the left-hand limit and the right-hand limit. So what the left limit looks like is the limit as x goes to some value. So we'll do it in the context of this one here. Limit as x goes to 3 minus. So it'll look like it's to the minus power when it's written out, but it's really meaning the limit as x goes to 3 from the left-hand side of whatever function it is, f of x. And then there's the right-hand limit, which would be looking like the limit of f of x as x goes to some value, we'll say 3, from the right-hand side, so it'll look like 3 plus. So really it's saying from the positive x direction and from the negative x direction. So if we're looking at it in the context of this one, if I want to know what the right-hand limit is, I want to know what the function is going towards as I come into this value from the right-hand side. So this would be the limit as x approaches 3 from the positive side. And it's equal to 6 because it's coming down towards 6. And then this would be the limit as x approaches 3 from the left-hand side, or the negative x direction. And it's also 6. Okay, so there's this nice thing that happens when these two limits are the same. When the left-hand limit matches the right-hand limit, we say that this limit exists. So if to state it in generic terms, we'll say if the limit as x approaches c from the left, so c minus of f of x, is equal to the limit as x approaches that same value from the right, then, and if they're equal to some value, L, some number, then the limit overall as x approaches c in general exists, and it's equal to that same value L. So like in this case, since the left limit and the right limit were both 6, then the overall limit is 6. But what if they don't match? So we're going to look at that case next. What happens when they don't match? Okay, so let's say I've got some function f of x let's go with okay. So there's our function. What if I wanted to know the limit as x approaches 4 from the left? Okay, so I would look at what it's doing, approaching from the left. It's going like that. It's approaching 2 as it comes in from the left. So my left-hand limit would be 2. But then let's take a look at the right-hand limit. So limit as x approaches 4 from the right. Well, we look at it coming in from the right instead this time, and we see that it's approaching 4. So in this case, my left-hand limit is 2, my right-hand limit is 4. So if I'm asked, does the limit as x approaches 4 of f of x, does that exist? No, it does not, because the right hand and the left hand limits don't match. So in order for this limit to exist, they must match. So we would say it does not exist, or DNE. Okay, so there's our intro to limits for today. Hopefully this was helpful. If you have any questions, feel free to comment below, send me an email, come to office hours, or all of the above. Have a wonderful day.